like PMF. Now we are talking about the PDF. So we need to satisfy the properties of PDF to find C. What does that mean? I have double integration of CDF should be 1. That is the property of PDF. So that means for y is from 0 to infinity, and for x is from y to infinity. So for y is from 0 to infinity, and for x is from y to infinity. You can do that the opposite way, that's fine. Minus y dx first, and then integrate y. So can take the c outside the integration, and because I'm doing the integration of x first, so I take the y outside. And if I take the integration of x, here is minus exponential to the minus x, and x is from y to infinity dy. Then I have c, and then take the second integration for y from 0 to infinity. And this one you can easily find. This is c. This is minus c divided by 2 e to the minus 2y, and y is from 0 to infinity. And this should be 1. Then we can find c equals 2. And now probably we want to find marginal PDF of x and y. So first, marginal PDF of x is from minus infinity to infinity. So I just take the integration of join the PDF of x, y, and integrate the y out. So it's dy. Y is from 0 to x. So here is 0 to x. And we know that c is 2. So 2 times exponential minus x exponential minus y dy. And this, I take the x outside. Then this integration is just minus e to the minus y. And y from 0 to x. And we finally get 1 minus exponential to the minus x. Now we need to know the index function because x is from 0 to infinity. So actually this function is x only from 0 to infinity. Similarly, the PDF of marginal PDF of y, I just integrate x dx. So you just put this to here and take the y outside and then integrate x. Finally you'll get 2 to the 2 times exponential minus 2y, and y is also from 0 to infinity. That is marginal PDF of x and y. Since you know the marginal PDF of x and y, you can find the expectation now. So the expectation for continuous random variable, I can consider all possible outcomes times their weighting. Their weighting is PDF of x. This we found from part B. So I have x is from 0 to infinity. X times 2 times minus 2 times exponential to the minus x dx minus x times 2 to the exponential 2 to the minus 2x dx. Now here you need to think it's from 0 to infinity, and also I have an exponential term. And what does that mean? If you know the exponential distribution, this actually is an exponential distribution with lambda equals 1. And here is the exponential with lambda equals 2. If this is the PDF of x times x, that means I'm trying to find the expectation. So here you can easily to find the expectation of the exponential distribution will be this minus 1/2. Finally, you got the answer is 3 divided by 2. This is a big trick and important things that you don't need to waste your time to have like do the integration by parts twice, which is really, really powerful. So we know since y is exponential random variable with lambda equals 2, that means the expectation of y is 1/2. Variance of y is 1/4. And also the variance of x, well actually, yeah, will be expectation of x squared minus the mean square. Then you need to find this. Again, I want to find the expectation of x squared, which is 0 to infinity, x squared times 2 times e to the minus x, 1 minus e to the minus x dx. Here I can have two parts. So it's 0 to infinity, 2 times x squared e to the minus x dx minus x squared e to the minus 2x dx. Now you see this is from 0 to infinity and exponential terms. So this is the exponential distribution with lambda equals 1. Here, exponential distribution with lambda equals 2. Then, and then you times x squared, so you want to find the expectation of x squared. That means 1 plus 1. This is mean square and variance. And for this second term, still the x squared, so that's the mean square plus variance. Mean square and variance. Finally, you get the answer is 7 divided by 2. So the variance is 5 divided by 4. Now part D, for find the expectation for xy. So now it's function of two random variables. The expectation will be double integral, and the possible outcomes times the weighting. The weighting is the joint PDF. And we know that's from 0 to infinity, and x is from y to infinity, xy times 2, which is c, dx dy. So you can integrate x first and then y. That means I put something outside for y only and take the integration for x. So here you can do the integration by parts, because now it's from y to infinity, not 0 to infinity. So you can, this is not the exponential random variable. So I will get minus x exponential to the minus x, and x is from y to infinity, plus y to infinity exponential minus x dx dy. Those you can do the arrangement. Finally, you have the integration from 0 to infinity 2 times y times e to the minus 2y dy plus 2 times y exponential minus 2y dy. Now you are expert. 0 to infinity and exponential here. So that's the should have a square. So let's say exponential with lambda equals 2. Here is also exponential with lambda equals 2. So this form, you want to find the expectation of the second moment, so which is variance plus mean square. And here you just find the mean, so it's 1/2. Then you get 1. Quite faster, right? Then next, the covariance and coefficient, correlation coefficient, is just plug in the formula, then you can get it. The covariance xy equals the expectation of xy minus expectation of x and expectation of y. Then you plug in, finally you get the answer is 1/4. And the correlation coefficient is just the covariance of xy divided by the square root of variance of x times variance of y. So you just plug in from the above answers to though, then you can get 1 divided by square root of 5.